In this video, we will discuss the reading assignment that I have assigned to you, that is lesson 1.2, Parabolas. So I will discuss some parts of this material that I think most of you will have difficulty in understanding it, and also the examples and some homework or seat work. So before we go to the definition, the formal definition of a parabola, let's first consider this figure. So we have point F at 0, 2, and the line L having the equation y equal to -2. What are the distances of point A at 4, 2 from F and from this point? This point is on L, that is closest to A. So if we simply count the units from F to A, we have 1, 2, 3, and 4. So we have 4 units. Also, from this point to A, we also have 1, 2, 3, and 4. So we have 4 units. So let's consider another point, -8, +8, which is on this point. Let's have approximately this point, that is -8, +8. Sorry for the wrong figure, wrong plotting of points. This is not -8, 8, so we have this one. So the question is, what are the distances of point B from F and from L, which is at this point? This is closest to B, that is on L, on line L. So if we use the distance formula, computing the distance from B to F or from F to B, we have square root of -8, this is x sub 1 minus x sub 2 plus y sub 1 minus y sub 2. So if we compute using calculator, that will give us 10 units. And also, from this point to point B, this is 8 units plus another 2 units, that will give us 10 units. So what are the realizations about these examples? That means that having any point on this curve, so let's have, what if this point, point P, the distance from point P to F is always equal to point P to a point on L that is closest to point P. So this distance is always equal to this distance. And the collection of all such points forms a shape called a parabola. So this is an example of a parabola. Okay, so for a formal definition of a parabola, let F be a given point and L a given line not containing F, the set of all points P such that its distance from F and from L are the same, is called a parabola. So the point F is called the focus of a parabola, and the line L, this line, is called the directrix of a parabola. Or we can say that a parabola is a set of all points in a plane equidistant from a fixed point called the focus and the line called the directrix, that is equidistant. And we also have another realizations here. This distance is also equal to this distance. This is the vertex of the parabola. Vertex of the parabola, we have the focus, we have the directrix, we have the axis of the parabola, and through this axis, the parabola is symmetrically U-shaped, and we can call this as distance C. So as we can see, a parabola does not have a center. It only has a vertex. So it is not an example of a central conic. Central conic, that means a conic has a center, but a parabola is not a central conic, so that means it has no center in it. So at this point, this is how the formula for the parabola was derived. So we have x squared equal to 4cy. That is the simplest of the formula. That is vertex at the origin. And the other one is x squared equal to negative 4cy. Also vertex at the origin. So the positive one, x squared equal to 4cy, that is a parabola that opens upward. So x and y here are points on this curve. 4 is a constant, and c is the distance, this one, the distance from the focus to the vertex. This is distance c, and also the distance from the vertex to this point on the directrix. So this is equal. The distance here is equal to the distance here, and let's call it distance c. Okay, so another parabola, that is x squared equal to negative 4cy. The negative here will tell you that the parabola is opening downward. So since x is squared, so we have a parabola that opens up and opens down. So still, this distance, let's call this c, that is the distance from vertex to this point on the directrix, and from this point, from the vertex to the focus, we also have distance c. So if the vertex is at the origin, that means the parabola opens upward, the vertex is the lowest point. So if it opens upward, this point will be the lowest of it, that is the vertex. And if the parabola opens downward, the vertex here is the highest point of the parabola. And the directrix for opens upward, for a parabola that opens upward, we have the line y equal to the negative of the distance c. And if we have a parabola that opens downward, we have the directrix, the line, having the equation y equal to positive c. So the directrix is the c units below or above the vertex. And how about the focus? The focus is c units above the vertex or below the vertex. So any point on the parabola has the same distance from the focus as it has from the directrix. And the axis of symmetry here. If we have a parabola that opens upward or downward, this is the axis of symmetry, this line. So this is the y-axis, or having the equation x equal to 0. Also with this is the axis of symmetry. This is x equal to 0.